Okay, it's step by step, right? So we're at 23 now. And then we're on the 23rd step. All right, what step we taken? We're going to look at contents. At least hope you do. The contents, generally speaking, are not long. I got to be honest with you, he packs a punch sometimes. He really does. But we're going to do the examples together. I'll do them at the whiteboard. No, you don't need to watch that if you don't need to watch that. If you're moving along at your own pace and the notes are sufficient for you, that's fine. And if my work's sufficient for you, that's fine too. All right? But some people need help. And some of the help you can get just a visual help of me going through the problems for you. All right? My name is Ron Bannon. This material is being prepared for the Prison Mathematics Project participants. All right? However, at some point, I do plan to publish this. When it's published, you can reach out to me, and I'll tell you how to get it. Right now, it's only being offered to the Prison Mathematics Project participants only. Someone says, what about the YouTube? Yeah, you can look at this. But the problem with looking at this is not the document. You're just looking at me scan through the document. And, certainly, the words he uses, the words I use, are going to probably be a little bit different. Time has changed over the last 100 years. All right? But he's talking about common factors, highest common factors, lowest common multiple, yada, yada, yada. And he talks about how to do it. All right? I would not worry so much about understanding everything everyone says. What you need to start worrying about is, are you able to do these things? And certainly we have techniques for it. And I'm not going to say my technique's any different than Wells's or anyone else's. They may sound different. But let's take a look at this. And I kind of read it to you. And what does it say? It says over here, give me a second, I've lost my palette for some reason. Let me see where the palette went. I don't know where it went. My pencil might be dying. Oh, there it is. For some reason, I wasn't expecting that behavior from it. Probably just not familiar with this program enough, right? So I realize he says highest common factor. Highest common factor. Well, I'll be honest with you. What I would say, I wouldn't say highest. I'd say the greatest common factor. And what I would do, whether it's in my head or on paper, I would need to know the factors of all those terms. Now, someone says this is an outrageous amount of work to write all the factors of those terms. But if you looked at the 42, I'm going to put this down for you. And someone said, what are the factors of 42? I would say 2 and 21. And then if you said, what are the factors of 21? I would say 3 and 7. And these are what's known as prime numbers. And that's why I'm putting these numbers down over here. Now, if you looked at, 70, I'll write that over here for you. And someone said, what are the factors of 70? I would actually say 2 and 35 at first. Then I'd look at 35, and I'd probably say 5 and 7. That's why I'm saying 2, 5, and 7 for the 70. Now, if you looked at 98, it's not that bad, by the way. Whoops, I did it again. If you looked at 98, I probably would start with a 2. I like to start low. It's a prime number, by the way. If you want to know what prime numbers are, they start at 2, and they're integers. They got to go up from the 2. And what are you doing? You're looking for numbers that are only divisible by themselves and 1. 3 would fit the description. 4 does not. 5 fits the description. 6 does not, because 6 is divisible by 2 and 3. What's the next number? 7. And this list does get difficult pretty quick. 8's no good. It's by 2. 9 divisible by 3. 10's by 2. Other numbers as well. And then I get to 11. 12 is no good. 13's fine. 14's bad. 15's bad. 16's bad. Then I get 17. And you could imagine that this list becomes quite difficult as you start moving up. But let's take a look at it. How about 98? 2 into 98 goes 49 times. Then I'm looking at 49, and I'm saying it's 7 times 7. They're prime numbers. So what numbers am I left with? Well, I'm hoping you're looking at it. 2, 7, 7. Okay, that's the 3 things of the numbers. Look at the letters. 3 factors of A, 2 factors of B. 2 factors of A, 1B, 1C. 4 factors of A, 3 factors of B, 2 factors of D. What I'm going to do now is I'm going to emphasize what they're saying. They want the highest common factor. I would not use that terminology. I would say the greatest common factor. Let's look at it. So I'm going to look at it. I'm definitely seeing 2. That's common, right? I'm definitely seeing 7. That's common. What about the A's? Let's see. Looks like I'm seeing 2 A's are in common. And let's look at the B's. I'm just going to say just 1 B in common. Yeah, a little kind of weird looking this notation, right? And there's no C in common. So what am I seeing? Let me write this down for you. A 2 is in common. A 7 is in common. 2 factors of A are in common. And 1 factor of B is in common. What's that give me? 14A squared B. Now, I got to be honest with you. That's a tremendous amount of work. I'm hoping at some point you're able to look at this and get a common factor pretty quickly. All right? Common factor. What I mean by that, the greatest common factor. All right? Now, this is more difficult, and I'll tell you why it's more difficult. It requires a factorization of each of those things. You're not going to get a common factor unless you can get them factored. So it depends on your ability to factor it. Just like I did over here, everything got factored. Let's take a look at this, and I'm going to look at it, and I'm going to say 5. I'm looking at the first guy here. It's my first term, so to speak. There's 2 terms to it, but I'm going to make it 1 term by factoring it. So I'm going to say 5x squared y. And what am I left off with there? X squared. Let's see. Minus, what times 5 would be 45? 9. I think I did okay there, right? And I can continue to factor that, believe it or not. Let me write that down for you. 5x squared y, x plus 3, x minus 3. So someone says, what are the factors of that? 5's a factor. There's 2 factors of x, 1 factor of y, 1 factor of x plus 3, and 1 factor of x minus 3. Now let's look at this guy over here, and I'm going to factor it. All right, so how would you factor that? Well, I think a 10 comes out from that, right? I'll put this over here. 10 looks like x, and it looks like a, let's see, what looks like y squared. Let's put down the rest of it. And what would that give me? Let's see, x squared, right? Plus 4x minus 21. Let's see, we got the x. Well, that's it. So I'm going to say maybe this factors further. All right? Now, someone's going to look at the 10 and say, can I write down 2 times 5? Yes, but I don't need to do that. So I'm just going to say this is 10xy. That's a square. And let's see if we can factor that. I'm going to say x and x. And I'm going to say 3 and 7 plus 7 minus 3. So I'm looking at, again, when I say I'm looking at something, we want you to be looking at those things too. All right? So I'll tell you what we're looking at. We're looking at this. I did it again. We're looking at this, and we're looking at this, and we are going to list the factors that they have in common. They certainly have a 5. They have an x. They have a y. And they have a factor of x minus 3 in common. And that's the greatest thing they have in common right there. All right? I want to encourage you to look at the answer key, and I do use this GCF. Again, Wells uses highest common factor. I just don't like that. I like to use the term GCF. What does GF stand for? Greatest common factor. All right? So what do you get? You get the exercises. You get to practice this skill set. And some people say they're get better than others. It's true. There's 3 guys here. What do you have to do? Well, I can't say enough times. This needs to be factored. This needs to be factored. That needs to be factored. Then you're going to look at the factors, determine what they have in common. All right? Same thing over here. This needs to be factored. This needs to be factored. That needs to be factored. Then what do you look at? What do they have in common factor-wise? All the answers are listed for you by. This needs to be factored. This needs to be factored. That needs to be factored. And by the way, I do put the work down for you. Do the work yourself, though. Don't look at the work and say, oh, gee, you did a good job. You need to do the job. This needs to be factored. That needs to be factored. That needs to be factored. What do? You look for common factors. So forth and so on. Get through all the problems. Someone says, it's too much work. No, it's not too much work. You get through that. What do you do then? You get to this related sage code stuff. If you have access to the internet, I do recommend you go there. What's Sage? It's a computer algebra system. All right? It's very powerful. It allows people to do things that they could not have done in the past. You can download the application if you have a computer that downloads software, or you can use the interactive web-based application. I do want to claim over here, though, that this thing's asking for things that you may see as being strange. GCD. What does that stand for? Greatest common divisor. It's the same concept, right? Same concept, all right? It is able to do it, and that's remarkable. It is remarkable, all right? Now, if you go to the SAGE website, you can look up all kinds of things about number theory, about algebra. It's really quite extensive, all right? If you need to reach out to me, though, for whatever reason, my email address is Bannon. That's B as in boy, ANNON.US. Again, this document is not published yet. When it's published, though, you'll have access to it. Thank you.